Having discussed the first part of the Matthew effect in science, when we discussed the reward and the communication systems proposed by Merton. Okay. Now, we will discuss the second part of the Matthew effect in science in the form of cumulative advantage and the symbolism of intellectual property. Okay. Now, when we discuss these two aspects against the backdrop of Matthew effect in science, namely cumulative advantage and the symbolism of intellectual property, I mean cumulative advantage on the one hand and intellectual property on the other, then what do these two terms reflect on? Okay. Cumulative advantage in science refers to the social processes through which various kinds of opportunities for scientific inquiry as well as the subsequent symbolic and material rewards for the results of that inquiry tend to accumulate for individual practitioners of science, as they do also for organizations engaged in scientific work. In here, Merton tried to look at individual practitioners of science, okay. Then he will move on to scientific community as such, then he will move on to the accumulation of scientific knowledge by the young professionals, I mean junior scientists, students, okay. And then he will get into accumulation of scientific knowledge by research organizations, research institutions. Okay. In this sense, we are trying to look at cumulative advantage in science, which refers, it is applied in the domain of science itself, which refers to the social processes through which various kinds of opportunities for scientific inquiry as well as the subsequent symbolic and material rewards for the results of that inquiry tend to accumulate for individual practitioners of science, I mean scientists themselves, as they do also for organizations engaged in scientific work. Such cumulative advantage in science directs our attention to the ways in which initial comparative advantages of trained capacity, structural location and available resources make for successive increments of advantage, such that the gaps between the haves on the one hand and the have nots on the other in science, as is envisaged in other domains of social life, which widen until dampened by countervailing forces, which what are countervailing forces we will discuss a little while later. Okay. But the way cumulative advantage in science is discussed here by Merton, okay, it directs our attention to the ways in which initial comparative advantages of 1. Trained capacity, 2. Structural location, 3. Available resources, which make for successive increments of advantage, such that the gaps between the haves and the have nots in science, as we find the similar trends in other domains of social life, which get widened until dampened by countervailing processes. This is the first part, that you will find that cumulative advantage in science. Then what is this intellectual property in science? Merton proposed the seeming paradox that in science private property is established by having its substance freely given to others who might want to make use of it. We have already discussed the ethos of science by Merton, where we discussed 4 ethos of modern science, namely universalism, communism, disinterestedness and organized skepticism. Okay. Communism is very integral to the debates on intellectual property in science. What did we discuss in communism? That the product or the process must be owned by the scientific community, must be owned by I mean, it must be owned by the scientific community in such a way that it will have a greater accessibility for the public. Okay. Now, due to intellectual property in science, the concept of private property is imposed on the fruits of such technological development born out of science. Okay. Now, Merton proposed a seeming paradox that in science private property, the notion of intellectual property, the notion of private property in a more capitalistic sense is established by having its substance freely given to others who might want to make use of it. Okay. In such a scenario, what we generally find that certain institutionalized aspects of this property system, chiefly in the form of public acknowledgement of the source of knowledge and information, thus freely bestowed on fellow scientists, relate to the social one, and second, cognitive structures of science in interesting ways that affect the collective advancement of scientific knowledge. When we say social structure of science and when we say cognitive structure of science, they should not be examined in isolation, and any attempt to study them in isolation will be misleading. Okay. Social and cognitive, they are interrelated. Okay. Cognition means ways to know. Okay. Now, the cognitive structure of science must be socially, politically, economically, culturally, institutionally, ideologically, legally, ethically embedded. Okay. Now, if in intellectual property in science, such institutionalized aspects of such property system in a more capitalistic sense, chiefly in the form of public acknowledgement of the source of knowledge and information, okay, which is freely bestowed on fellow scientists, relate to these two structures of science, namely social on the one hand and cognitive on the other, in interesting ways that affect the collective advancement of scientific knowledge. Okay. Now, in this lecture, what we are going to do, we are going to look at the Matthew effect in its generality. Okay. I mean the Matthew effect in science in its generality, okay. The accumulation of advantage and disadvantage for scientists, accumulation of advantage and disadvantage among the young scientists in particular, then accumulation of advantage and disadvantage among scientific institutions, research organizations, research institutions, then followed by countervailing forces and the symbolism of intellectual property in science. Okay. Now, let us see how the Matthew effect in science in its generality may be discussed. Okay. Let us begin by noting a theme. Okay. Let us begin by noting a theme that runs through Harriet Jakerman's hours-long interviews with Nobel laureates in the early 1960s. As we have already discussed, Harriet Jakerman was a collaborator of Robert Merton. Merton banked on Jakerman's interviews with Nobel laureates to locate, to posit inequalities in science. Okay? And it is repeatedly suggested in those interviews conducted by Harriet Jakerman, okay, that eminent scientists get disproportionately great credit for their contributions to science, while relatively unknown scientists, relatively less known scientists tend to get disproportionately little for their occasionally comparable contributions. Okay? Let us put it this way, if I can do this, that for example, a prize will almost always be awarded to the most senior researcher involved in a project. even if all the work has been was done by a graduate student or a junior scientist. Okay. If you look at the slide here, that the world of science is just like a pyramid structure or a triangle, where at the lower level you will find more and more scientists with a very few rewards and recognitions. The world of science has been structured in such a way that at the top there will be a very few scientists with more rewards and recognitions, even if all the work has been done by lesser known scientists or graduate students. Okay. Such unequal structure that you see on the slide, that the world of science has created, I mean the world of science has been structured in such a way that it has created such inequalities. Okay. In this context, it is important to note from Zuckerman's interviews with Nobel laureates that how eminent scientists get disproportionately great credit for their contributions to science, while relatively unknown scientists, relatively lesser known practitioners of science tend to get disproportionately little for their occasionally comparable contributions. Okay. This is very important. Buttressing the argument, strengthening the argument further, one Nobel laureate told Harriet Zuckerman once in the process of such interviews that the world is peculiar in this matter of how it gives credit. It is a peculiarity. Okay? The world is peculiar, including the world of science is peculiar in this matter of how it gives credit. It tends to give the credit to already famous people, to already known people. Okay? This is very important. The claim that prime recognition for scientific work by informed peers and not merely by the inevitably uninformed lay public is skewed in favor of established scientists requires indeed that the nature and quality of these diversely apprised contributions be identical or at least much the same. That condition, such condition is approximated in cases of full collaboration and in cases of independent multiple discoverage. That is why Merton was giving the example of Newton and Leibniz earlier, we have already discussed. Okay. If you look at history of science history of physics, history of mathematics, okay, you will find the kind of controversies which arose in the context of the works of Newton as well as Leibniz. Okay. Such condition is approximated in cases of full collaboration and in cases of independent multiple discoveries. At least now independent multiple discoveries have been attributed to the controversies between Newton and Leibniz. Okay? It is very important. Such inequality persists in the world of science itself, as we have discussed in this slide. Okay? The distinctive contributions of collaborators are often difficult to disentangle independent multiple discoveries, if not identical or at least enough alike to be defined as functional equivalents by the principles involved, principal investigators involved, or by their informed peer groups. It is designed in such a manner that the whole lot of relatively lesser known scientists, practitioners of science will be left out of the way the world of science has been structured. Okay. It is important to know, it is important to understand such misallocation of recognition, that how a very few scientists get all accolades, okay, even if much of the work has been carried out by the junior scientists or graduate students, PhD students. Okay. A Nobel laureate in physics told Zuckerman that the man who is best known gets more credit and inordinate amount of credit. A Nobel laureate in chemistry puts it this way, that, let me quote here, if my name was on a paper, people would remember it, not remember who else was involved. The biological scientists like R.C. Leontin and J.L. Hubby have lately reported a similar pattern of experience with a pair of their collaborative papers. Okay? I mean, in terms of citation classics. Okay? I mean, even if less significant, less prominent authors have contributed to the designing of a paper, if less to the making of that paper, the more well known scientists get the all the accolades. The way Leontin and Hubby described the matter of the Matthew effect, I mean, not the way Merton tried to do that, tried to theorize upon it. Okay. They also tried to reflect on this aspect of inequalities in science in terms of their own Lebenswelt. Lebenswelt, I mean, it is life world. Okay. It is a French German word. Okay. In Latin also people use Lebenswelt. It means life world. Those Nobel laureates, namely Leontin and Hubby, they were trying to say that one paper was cited some 310 times, the other some 525 times. The first paper described a method, and the second, let me quote here, it is very interesting. If the first paper described a method, the second paper gave the detailed result of the application of the method to natural populations. The two papers were a genuinely collaborative effort in conception, execution and writing, and clearly form an invisible pair, published back to back in the same issue of the journal. The order of authors was alternated, with the biochemist Hubby being the senior author in the method paper and the population geneticist Leontin as senior author in the application paper. Okay. Yet paper 2 has been cited over 50% more frequently than paper 1. I mean, the application paper has been cited more frequently than the methodological paper. Okay. Then citations to paper 1 as both laureates, both Nobel laureates, namely Leontin and Hubby, they put it that citations to the methodological paper virtually never stand alone, but are nearly always paired with a citation to the application paper, the paper with application. But the reverse is not true. Wherever the paper with application has been cited, it is not necessary that the methodological paper also has been cited. Why? I mean, what is the reason of this? We seem to have a clear-cut case of Merton's Matthew effect. That is what they were trying to see, both Nobel laureates. They were trying to look at Mertonian inequalities in science, Mertonian Matthew effect in science, in terms of rewards, in terms of recognitions, in terms of cumulative advantage in science, and in terms of symbolism of intellectual property in science. Okay? That the already better known investigator in a field gets the credit for joint work irrespective of the order of authors on the paper, and so gets even better known by an by an autocatalytic process. In 1966, Leontief had been a professional for a dozen years and was well known among the population geneticists to whom the paper was addressed, while Hubby's career had been much shorter and was known chiefly to biochemical geneticists. Okay? As a result, the population geneticists have consistently regarded Leontief as the senior member of the team and given him undue credit for what was a completely collaborative work that would have been impossible for either one of us alone. That is what this suggests, both of them. At the extreme, if you look at this, okay, at the extreme, such misallocation of credit can occur even when a published paper bears only the name of a hitherto unknown and uncredentialed scientist. Let us consider this observation by the invincible geneticist and biochemist. We all know him, I mean STS scholars also know him as a top class historian of science, JBS Haldane, whose not having received a Nobel Prize can be cited as prime evidence of the fallibility of the judges in the Swedish Academy of Sciences. I mean, in Stockholm they decide Nobel Prize, and we all know what kind of problems it can pose. Speaking with Ronald Clark of SK Roy, his talented Indian student from India, who had conducted important experiments designated to improve strains of rice, Haldane observed that JBS Haldane, I said he was a great geneticist and biochemist, eminent historian of science as well. Okay. Haldane observed that Roy himself deserved, I mean that student from India, he himself deserved 95% of the credit. The other 5% may be divided between the Indian Statistical Institute in Kolkata and myself means Haldane himself. He added, Haldane deserves credit for letting him try what he thought was a rather ill-planned experiment on the general principle that Haldane himself is not omniscient. But Haldane had little hope that credit would be given that way. Every effort will be made here to crab his work. He wrote, he has not got a PhD or even a first class MSc, I mean Roy. Okay. So, either the research is good or I did it. I mean Haldane mentioned this. Okay. Now, if you look at this, such misallocation of rewards, misallocation of recognitions that we have seen in this slide in the world of science, I mean where more scientists are endowed with of very few rewards and recognitions, and a very few scientists with more rewards and recognitions, accolades. What do we find? That it is such patterns of misallocation of recognition for scientific work that Merton described as the Matthew effect. The not quite foreordained term derives of course from the first book of the New Testament, the Gospel according to Matthew. In the stately prose of the King James Version, created by what must be one of the most scrupulous and consequential teams of scholars in Western history, the well remembered passage reads, for unto everyone that hath shall be given, he shall have abundance, but from him that hath not shall be taken away even that which he has. I mean this is a clear case of the distinction between the haves and the have-nots. Okay. Now from such I mean we must go beyond, we must make a shift from such spiritual account of inequality to a more secular account of inequality. Okay. And that is what Merton also said, that let us move on to, but let us take this account, okay, let us use this term to make sense of the data which have been derived from Zuckerman's interfuge. Now, the Matthew effect is accruing of large increments of peer recognition of two scientists of great repute for particular contributions, in contrast to the minimizing or withholding of such recognition for scientists who have not yet made their mark. The biblical parable generates a corresponding sociological parable. That is that is why we must make this shift from a biblical account to a more sociological account or to a more secular account. Okay? For this is the form, it seems, that the distribution of psychic income and cognitive wealth in science also takes. How this comes to be and with what consequences for the fate of individual practitioners of science and the advancement of scientific knowledge are the questions in hand. Okay? Now, it is very important to understand such dynamic. Okay? Now, what we have discussed till now in these 20-25 minutes, that what we have discussed the Matthew effect in the context of cumulative advantage in science as well as the symbolism of intellectual property, but we have not yet come to in detail, at length and in detail, cumulative advantage and intellectual property in science. We will come to this point. Okay? Partly we have covered cumulative advantage, but we will come to cumulative advantage in much detail now. Okay? What we have discussed, cumulative advantage in science, which refers to the social processes through which various kinds of opportunities for scientific inquiry as well as the subsequent symbolic and material rewards for the results of that inquiry tend to accumulate for individual scientists as they do also for organizations engaged in scientific work. That is why individual is always a part of that institution. Okay? Further, cumulative advantage in science directs our attention to the ways in which initial competitive advantages of trained capacity, structural location and available resources make for successive increments of advantage, such that the gaps between the haves and the have-nots in science, the gaps between more well-known scientists with a very few more well-known very few well-known scientists with more rewards and recognitions on the one hand, and more scientists with no recognition. As the gaps between the haves and the have-nots in science widen until dampened by countervailing processes. What are the countervailing processes? We will discuss. Okay? Further, intellectual property in science, as Merton proposed, that the seeming paradox that in science private property is established by having its substance freely given to others who might want to make use of it. And certain institutionalized aspects of this property system, chiefly in the form of public acknowledgement of the source of knowledge and information thus freely bestowed on fellow scientists, relate to the social and cognitive structures of science in interesting ways that affect the collective advancement of scientific knowledge. Thus, the social and the cognitive structures of science should not be treated in isolation. Then we discussed the Matthew effect in science in its generality. Okay? How eminent scientists get disproportionately great credit for their contributions to science, while relatively unknown scientists tend to get disproportionately little or nothing for their occasionally comparable contributions. This is how, for example, we discussed a prize will almost always be rewarded to the most senior researcher involved in a project, even if all the work was done by a graduate student or a junior scientist. That is, this is how we try to look at the world of science. This is how we look at the ways in which the world of science has been structured, and where you will find the world of science is structured in such a way that it poses it has an internal structure that which is externally conditioned, that where you will find more scientists with a few rewards and recognitions, and a very few scientists with more rewards and recognitions at the top level. That is why we have put it this way, that more scientists with a few rewards and recognitions at the bottom level. At the bottom you will find many scientists with little recognition, but at the top you will find a very few scientists with more rewards and recognitions. Okay? That is why in the words of a laureate, Nobel laureate, as Zuckerman puts it, that the world is peculiar in this matter of how it gives credit. It tends to give the credit to already famous people, to already well known people. Okay? Then we discussed how the claim that prime recognition for scientific work by informed peers and not merely by the inevitably uninformed lay public is skewed in favor of established scientists requires, of course, that the nature and quality of these diversely appraised contributions be identical or at least much the same. And such condition is approximated in the cases of full collaboration or in the cases of independent multiple discoveries that we have already discussed in the context of the controversies between Newton and Leibniz, and such distinctive contributions to collaborators are often difficult to disentangle independent multiple discoveries, if not identical, or at least enough alike to be defined as functional equivalents by the principal investigators involved or by their informed peer groups. And it is such patterns of the misallocation of recognition, where your work remains or your work goes unrecognized for the scientific work, that Merton described as the Matthew effect. The not quite foreordained term derives, of course, from the first book of the New Testament, the Gospel according to Matthew. This is a spiritual account. I mean, this is not what we are doing here. It is, we are trying to make a shift from, we are taking the turn from such biblical account, but we are trying to make a shift from such spiritual account of inequalities in science to a more secular account of inequalities in science. In the stately prose of the King James Version, created by what must be one of the most scrupulous and consequential teams of scholars in Western history, the well remembered passage reads, "For unto everyone that hath shall be given, and he shall have abundance, but from him that hath not shall be taken away even that which he hath." I mean, for unto everyone that has shall be given, and he shall have abundance, but from him that has not shall be taken away even if that which he has. I mean, hath in this sense, I mean in English it is has. Okay? I mean, this is also English, but the earlier usage of English was hath, I mean in the biblical account. Okay? And the Matthew effect is the accruing of large increments of peer recognition to scientists of great repute for particular contributions, in contrast to the minimizing or withholding of such recognition for scientists who have not yet made their mark. The biblical parable generates a corresponding sociological parable. That is what I said. I mean, we must make a shift from such biblical or spiritual account to a more sociological account, to a more scientific account, or to a more secular account, okay, to posit such inequalities in science. For this is the form, it seems, that the distribution of psychic income and cognitive wealth of science also takes place. How this comes to be and with what consequences for the fate of individual scientists and the advancement of scientific knowledge are the questions in hand. From here onward, we will move on to the accumulation of advantage and disadvantage for scientists, then we will move on to the accumulation of advantage and disadvantage among the young scientists, junior scientists, graduate students, PhD students. Then we will move on to accumulation of advantage and disadvantage among scientific institutions, research organizations, research institutions, and so on, followed by countervailing processes and the symbolism of intellectual property in science. Okay. Now, let us start with the accumulation of advantage and disadvantage for scientists. Taken out of its spiritual context, okay, and placed in a wholly secular context, the Matthew doctrine, the Matthew effect would seem to hold that the posited process must result in a boundlessly growing inequality of wealth. However, wealth is construed in any sphere of human activity, conceived of as a locally ongoing process and not as a single event. The practice of giving on to everyone that has much while taking from everyone that has little will lead to the rich getting forever richer while the poor become poorer. Increasingly absolute and not only relative deprivation would be the continuing order of the day, but as we know, things are not as simple as all that. After all, the extrapolation of local exponentials is notoriously misleading. In noting this, Merton did not intend to assess the current economic theory of the distribution of wealth and income. Instead, Merton reported what a focus upon the skewed distribution of peer recognition and research productivity in science has led some of us to identify as the processes and consequences of the accumulation of advantage and disadvantage in science. Okay? I mean, further, I mean, when Merton tried to look at when Merton first stumbled upon the general question of social stratification in science in the early 1940s, one paper of that period alludes to the accumulation of differential advantages for certain segments of the population, differentials that are not necessarily bound up with demonstrated differences in capacity. It would not be correct or indeed just to say that the text is no clearer to anybody now than the notoriously obscure anything was clear to somebody else. Okay? That is why for such things the notion of cumulative advantage in science had led only to a ghostly existence in private musings, sporadically conjured up for oral publication rather than put in print. Further investigation of the process of cumulative advantage took hold in the later 1960s with the formation of a research quartet at Columbia consisting of Harriet Zuckerman, Stephen Cole, Jonathan R. Cole and Robert King Merton. Okay? I mean, if you look at this galaxy of thinkers, okay, you will find their works not only in humanities and social sciences, but also in sciences, engineering. Okay? They had enormous impact, their writings had enormous impact on the world of sciences as well as the world of humanities and social sciences. There has since emerged an invisible college, as Merton put it. In fact, the invisible college, I mean, that was coined by Derek D.J. Sola Price. Okay? What is that? What does that refer to? Okay? That is to adapt the brilliant terminological recoinage by Sola Price, which has grown apace in contributing to a program of research on cumulative advantage and disadvantage in social stratification generally and in science specifically. Okay? See, one must remember the difference between stratification, hierarchy and so on, but this is not a course in Introduction to Sociology which I had earlier offered in under NPTEL. Okay? But still one must remember the vertical and horizontal aspects of both stratification as well as hierarchy. If you want, you can look at the lecture notes of NPTEL, lecture notes of Introduction to Sociology, which I developed under NPTEL phase 2. Okay? Notably, including Derek D.J. Sola Price himself until till his sad demise, that college also numbers Allison, Barber, Blow, and others, there are so many. Okay. This surely, when we discuss Solaprice's Invisible College in the context of such social stratification in science, okay, differentiation in science, differential treatment in the world of science to its own practitioners. Okay. This is not the occasion for providing a synopsis of that now considerable body of research materials. Rather, what Merton did, Merton only reminded us of a few of the marked inequalities and strongly skewed distributions of productivity and resources in science, and then focus on the consequences of the bias, focused on the consequences of such bias, prejudice in favor of precocity that is built into our institutions for detecting and rewarding talent, and institutionalized bias that may help bring about severe inequalities during the life course of scholars, including scientists. Okay. Then let us first have a quick sampling of the abundance of conspicuously skewed distributions and inequalities identifiable at a given time. Okay. Then Merton tried to provide certain examples to look at how such sampling of the abundance of conspicuously skewed distributions and inequalities, okay, within science. The total number of scientific papers published by scientists differs enormously, ranging from the large proportion of PhDs who publish one paper or none at all to the rare likes of many scholars who have produced many papers from their PhD thesis, okay, like William Thomson, Kelvin with his 600 plus papers, or the mathematician Cayley publishing a paper every few weeks throughout his work life for a total of almost 1,000. Okay. Secondly, the skewed distribution of the sheer number of published papers is best approximated by variants of Alfred J. Lotka's inverse square law of scientific productivity, which states that the number of scientists with n publications is proportional to n square. Okay. In a variety of disciplines, this works out to some 5 to 6% of the scientists who publish at all producing about half of all papers in their disciplines. Okay. Even when I talk to my PhD students, I very often tell them, not always, but I very often tell them that you publish or perish. Okay. But when you look at publications, over a period of time, okay, I always feel that instead of publishing perishable items, one must refrain from publishing. This is very important. We'll discuss these things. These items or these notions always these notions always propel us to think beyond the world of publications. Okay. It doesn't imply that one should not publish, one must publish, but instead of publishing perishable items, okay, one must refrain from publishing. One must publish something which is novel. One must publish something which has not been touched upon by others. One must build on those existing materials to come up with something new. That newness may be maybe at a very rudimentary stage, maybe at a very elementary stage, but one must be able to publish new things. Okay? That is how we tend to look at the tradition of cumulative knowledge production. Okay. The distributions in publications are even more skewed in the use of scientists' works by their peer groups, as that use is crudely indexed by the number of citations to it. Much the same distribution has been found in various data sets. Typical is Garfield's finding that for an aggregate of some 19 million articles published in the physical and biological sciences between 1961 and 1980, 0.3% were cited more than 100 times, another 2.7% between 25 and 100 times, and at the other extreme some 58% of those papers, articles that were cited at all were cited only once in that 20 year period. This inequality you will recognize is steeper than Pareto like distributions of income. Vilfredo Pareto, if somebody is very interested to look at that, one can look at Vilfredo Pareto's economic theory of distribution of income. Okay. When it comes to, but this is not a part of our exercise, but I am just trying to give you certain examples where somebody can go very interdisciplinary, as STS itself is interdisciplinary. That is why I said from the very beginning, I said STS is such an interdisciplinary exciting enterprise that you will find that it is a conglomeration of philosophy of science, history of science and sociology of science. Now many aspects, many fields of inquiry, they also contribute to the development of STS. Okay. For example, literature, okay, it is very important. Linguistics, very important. Okay. We must, anthropology, psychology, okay, they are very important. When it comes to changes in the extent of inequalities of research productivity and recognition during the course of an individual's work life as a scientist, the needed longitudinal data are much more scarce. Again, a few suggestive findings which Merton has provided are like this. I mean, in their simulation of longitudinal data through disaggregation of a cross section of some 2000 American biologists, mathematicians, chemists and physicists into several strata by career age, Paul D. Allison and John A. Stewart found that a clear and substantial rise in inequality for both the number of research publications in the preceding 5 years and the number of citations to previously researched work from the younger to the older strata, strongly supporting the accumulative advantage hypothesis. Allison and Stewart secondly also confirmed the Zuckerman-Merton hypothesis that decreasing research productivity with increasing age results largely from differing rates of attrition in research roles, and that this approximates an all or none phenomenon. The hypothesis held that the more productive scientists recognized as such by the reward system in science, reward system of science, tend to persist in their research roles, while those with declining research productivity tend to shift to other indispensable roles in science, not excluding the conventionally maligned role of research administrator. Derek D.J. Sola Price pointedly reformulated and developed that hypothesis of Zuckerman and Merton. Okay? That what was that hypothesis? That decreasing research productivity with increasing age. Okay? That because there is a very large but decreasing chance that any given researcher will discontinue publication. The group of workers that reaches the research front during a particular year will decline steadily in total output as time goes on. Gradually, one after another, they will drop away from the research front. Thus, the yearly output of the group as a whole will decline, and now comes the essential point Zuckerman and Merton tried to emphasize. Even though any given individual within it may produce at a steady rate throughout her or his entire professional lifetime. That is why it is important to distinguish this effect of mortality at the research front from any differences in the actual rates of productivity at different ages among those that remain at the front. It is very important. With regard to the Matthew effect and associated cumulative advantage in science, what Stephen Cole found in an ingeniously designed study of a sample of American physicists, that the greater their author's scientific reputation, the more likely that papers of roughly equal quality as assessed by the later number of citations to them will receive rapid peer recognition by citation within a year after publication. Okay? Prior repute of authors somewhat advances the speed of diffusion of their contributions. Stephen Cole further found that it is a distinct advantage for physicists of still small reputation or little reputation to be located in the departments most highly rated by peer groups, that their new work diffuses more rapidly through the science networks than comparable work by their counterparts in peripheral university departments. Then we will discuss accumulation of advantage and disadvantage, okay, among the young scientists, among the junior scientists, among the graduate students, among the PhD research scholars. Okay. It is very important to understand this. Then what we have discussed till now? We have discussed the Matthew effect in its generality in terms of cumulative advantage, and we will discuss later on the symbolism of intellectual property. Then we have discussed cumulative advantage in science, which refers to the social processes through which various kinds of opportunities for scientific inquiry as well as the subsequent symbolic and material rewards for the results of that inquiry tend to accumulate for individual practitioners of science, scientists themselves, as they do also for organizations engaged in scientific work. Cumulative advantage in science directs our attention to the ways in which initial comparative advantages of three things: trained capacity, structural location and available resources make for successive increments of advantage, such that the gaps between the haves and the have nots widen until dampened by countervailing force processes. Those countervailing processes will be discussed a little while later, and such gaps between the haves and have nots are not only found in the world of science, but also are found in the domains of other domains of social life. Then intellectual property in science, we have discussed how certain institutional aspects of this property system, chiefly in the form of public acknowledgement of the source of knowledge and information, thus freely bestowed on fellow scientists, relate to the social and cognitive structures of science. We have discussed the Matthew effects in its generality. We have discussed the world of science, the way it is structured. We have discussed. We have also discussed how the world of science is peculiar in a matter of how it gives credit. It tends to give the credit to already famous people. And then we have discussed the accumulation of advantage and disadvantage for scientists. In the lectures to follow, we are going to discuss the accumulation of advantage and disadvantage among the young scientists, the accumulation of advantage and disadvantage among research organizations, scientific institutions, research institutions and so on, then followed by countervailing processes and the symbolism of intellectual property in science. Thank you.